Welcome to the next video about the mistakes people make in CAIE exams. This time is the turn of Pure Math 2 and 3 exam, which is 9709/31, 32 or 33. If you like this video, please subscribe to my channel, share this video with your friends so that they also get benefited, and I make many more videos like this. Let's start with mistake number 1, which is about partial fraction. If suppose you have 3x squared over x plus 2, 2x minus 5, and they ask you to separate the denominators by partial fraction, do not start the partial fraction straight away. Why? Because look at the degree of the numerator 2, and if I multiply x and 2x, it gives me 2x squared. That means degree of the denominator is also 2. So if the degree of numerator is greater than or equal to the degree of denominator, you can't carry out partial fraction straight away. You will have to divide 3x squared in this case first by the denominator. Expand this, which will be how much? 2x squared, and then it will be 4x minus 5x minus x minus 10. You have to divide this long division first, and whatever quotient, suppose you get a quotient here which is something, and then you get a remainder here, your new question will be quotient plus remainder over x plus 2, 2x minus 5, and then you will carry out partial fraction. Never ever start with partial fraction straight away here if the degree of denominator is greater or equal to the degree of denominator. So the summary says, if degree of numerator is greater or equal to degree of denominator, carry out long division first and then proceed with partial fraction. Okay, mistake number 2. It happens with the binomial expansion. Let me give an example. 3 plus x to the power minus 2/3. We need to expand this, say, first 3 terms only. Okay. So the formula you are given in the exams, let me show you that formula. Here it is. So you can clearly see here this formula is for 1. Alright. There is a formula for some constant plus x also, but that is not given in exams. So how to convert this particular into this format so that we can use this formula? So we can do this way. The question is 3 plus x to the power minus 2/3, right? Do what? Take 3 common and it becomes 1 plus x over 3 to the power minus, rather we'll have to do this one, minus 2/3. Pause the video and try to understand this. If I expand this again, 3 times 1 will be 3 and 3 times x over 3 will be x again. So I did not change it, I just broke it into 2 parts so that this particular part matches with this. It becomes 1 plus something, that's what I need, and this is 1 plus something now. So now I will take this 3 out so that I expand only this one. So this can be written as 3 to the power minus 2/3 outside. So whenever 3 comes out of the brackets, it comes with the exponent it had. And what are we left with here? Rather, let me only write 1 plus x over 3 now. 1 plus x over 3 to the power minus 2/3. And this we can expand according to this formula. They said first 3 terms, so we will use these 3 terms and we'll get our expansion. People usually use the same formula, and in place of this one they will write 3, and then because there is nothing multiplying here, they will keep on multiplying by 3, which is not right. So the summary is here. Convert some constant plus x to the power n into this format by factoring out k. That's how you can use the formula given to you in the exam. Next, is actually not a mistake, but yeah, because people do not remember how to draw the graph of y equal to secant x or y equal to cosecant x or y equal to cot x. They spend a lot of time in drawing it, whereas they ask you just draw between 0 and say pi. And they make a table and it takes a lot of time and sometimes you don't get a good graph also. So the best thing is that you should remember the graphs of sine theta, cos theta and tan theta. Let's say y equal to sine theta. What is the graph of y equal to sine theta? Here, this is 2 pi, this is 0, and maximum value of sine is 1, minimum value is minus 1. So now if I want to draw the graph of cosecant theta with the help of y equal to sine theta, I can draw it very easily because we know that cosecant x will be equal to 1 over sine x. So whatever is the y value of this sine graph, just reciprocate and you get the value, you get the graph of cosecant x. So let me try to draw the graph of cosecant x just below this. So 2 pi is here. This middle one will be pi. And then we'll get some graph. Okay, so let's reciprocate 0 first. What is reciprocal of 0? Because y value is 0 here. Undefined, right? That means this particular line, y-axis, will be an asymptote, a line which is not touched by the graph. Similarly, this is 0 pi, so there will be an asymptote, draw a dotted line here. 2 pi is 0, it will be a dotted line here. That means graph will not touch these three lines. So what will that be? Just take these extreme points. What is the reciprocal of 1? 1. So if this is 1, this will be the point here. Reciprocal of minus 1 is minus 1. And now take some random point, say 0.5 here, 0.5 here. What is the reciprocal of 0.5? 2. So 2 will be somewhere here and here. So that means the graph of cosecant x is this, not touching these lines, and it will be inverted here, not touching these lines. And we got the graph so easily. If we remember this very clearly, how the sine, cos and tan graphs look like, just reciprocate them and you'll get the graph of cosecant, cosecant and cot. And here is the summary of what I just said. Number 4 happens in these kind of questions where you have a formula first in the first part, and in some other part they say let's show that if the sequence of values given by the iterative formula, this one, it converges with these roots, whatever root you are getting from the first side. In other words, they are saying that convert this into this or convert this into this. That's what they're trying to say. And in such a case, people are confused. What do we do with xn plus 1 and xn? They are different numbers. Understand it very clearly that this n plus 1, xn plus 1 and xn are same x. We got it from here. That means if we want to convert this into this first equation, xn plus 1 becomes x, xn also becomes x, and this xn plus xn also becomes x. All of them become x and it becomes easy. So x plus 48.5 x equal to 50 sine x, right? Now x plus 48.5 will be 49.5 x equal to 50 sine x. Divided by 50 because we want sine x only. Divide here by 50, cancel out. We want 99, so multiply here 2, multiply here by 2, so we get 99 over 100 x equal to sine x, and we got this one. And here is the summary. Whenever they ask you to show that one equation converges according to the second one, just convert one into the other. And this is very important to remember. Xn plus 1 and xn both are x in that case. Okay, let's move on to the mistake number 5. In mistake number 5, people do this. Suppose there is an argument z minus I plus 3 is equal to pi by 4. This is what they're saying, and show it on an Argand diagram. So what usually students do in hurry or in lack of knowledge, they draw minus I plus 3. So 3 is the real part. So on real axis, we will write 3, 1, 2, 3. And minus I is imaginary, right? So this is, according to them, minus I plus 3, which is correct. But we do not use it as it is. We always must change it to this format, z minus z1, and that means z1 will be I minus 3 equal to pi by 4. The format of argument, and for that matter the modulus also, z minus z1, this should be the format of argument or the modulus, both of them, z minus something. Okay, this is unknown complex number which is in reference with this particular point, which is achieved after we bring out minus out of it. So our actual point is I minus 3, not minus I plus 3. So where is the actual point? Let me show you it with different color now. It is positive I here, and minus 3 is real. Minus 3 is suppose here 1, 2 and 3. This is the point where you have to draw the argument of pi over 4. This is the argument. Otherwise you would be drawing this wrongly, which is not acceptable at all. And here is the summary. Convert every argument or modulus equation. Equation means it may be equal to 3, it may be equal to 1 over 4 pi. All of them should be converted to this format by bringing out minus out of whatever z1 they have given. Mistake number 6 is about logs. We know that log A plus log B equal to log AB. This is the law of logarithm, right? But sometimes we come across this log A multiplied by, which is means log A is whole, multiplied by log B, and students think that we can do the opposite also, log A plus B. No, we can't do this. It is only when log of a number plus log of another number they are adding, so their contents multiply. Whatever numbers they are after them, they are multiplied. But if the logs themselves are multiplying, we have no such formula. So this one is invalid step. You need to do something else, but you can't do this. So I'm not summarizing this. I hope this is clear enough. Moving on to mistake number 7 and 8 together. They are both about exponential integration. So let me write an example of this. Suppose we have a very simple integration of e to power 5x plus 3 dx, right? So we have to integrate, we just copy this, that is the integration, e to power 5x plus 3 and divide by 5, right? But what happens that in exam scenario under pressure, people do it like differentiation. They multiply by 5, and that creates a lot of trouble. Your answers are wrong and you go in wrong direction. So please, please, please do not confuse between when we divide and when we multiply. We multiply when we differentiate. We divide by the differentiation of exponent when we integrate. This is a very small mistake, but it causes a lot of trouble. Mistake number 8 is also about integration of exponential. Suppose I have e to power 3x minus 2 square dx. I want to do this one. Alright, I want to integrate this one. So since e to power 3x is easy to differentiate or integrate like this, people just do this. E to power 3x minus 2, 2 plus 1 over 2 plus 1, and divide by the differentiation of what is here, which is e to power 3x over 3, right, plus c. And obviously many of you might have seen this is completely wrong. We cannot apply this method with exponential ones. Rather, we can only apply this with linear. if there is 3x plus 5 to the power 6, we can apply this because the content of this bracket is a linear function. Here only we can do this kind of integration. Otherwise, how do we do this? We will have to expand this. So expand this first, so it will become e to power 6x plus 4 minus 4 e to power 3x. This is when I expand the square and I get a very easy kind of integration after that. So we can integrate it like normal method now. It will become e to power 6x over 6 plus 4x minus 4 e to power 3x over 3 plus c. Okay, so please take care of these two, mistake number 7 and 8. And here is the summary of the two examples I've just given. Next mistake is about trigonometry. Suppose I have one equation 3 sine x minus 5 cos x, that is the function, right? Fx. This is the function. What is the maximum value of this? That's the question. Okay, so some students start drawing graphs for this and try to see what is the maximum value, or they will see, okay, 3 minus 5 minus 2 and 3 minus 5, which is 8. So 8 is the maximum value and minus 2 is the minimum value. Just they guess this one. Never do that. This is completely wrong. What we should do, that we know that this kind of function can be converted to r sine or cos. In this case, let's say sine. Sine a minus b format, right? Rather x minus alpha format. Okay, I'm just making it up. So this is the angle and it's a simple sine function now, right? And the maximum of a sine function is the amplitude, whatever is the amplitude. So if we can find r, we'll find the maximum, and r is a shortcut, just square root, square this and square this, that will be the answer. That's how we do. We have done many such questions in past papers. So 9 plus 25 square root 34 is the value of r, and it becomes the maximum value. If they ask you the minimum value, negative of this will be your minimum value. So no need to go in details of how this will be done. If they are asking just maximum or minimum value, yes. If they are asking you to convert into this format, then you do the whole process which we have done in many of the questions. Sometimes they may even complicate this even further, that 3 sine x minus 5 cos x plus 7, find its maximum value, right? So we know, we just found out that for this the maximum value is 0 square root 34. So separate this and find its maximum value, and because this is also, because fx is y, so just add 7 to this and that becomes maximum value. There is nothing difficult in this if it is in this format. And here is the summary. Convert a sine plus minus b cos x in r sine x plus or minus alpha format first, and then r will become the maximum or minimum value with negative. Alright. One thing you need to keep in mind, that x plus alpha is angle, and angle has no role whatsoever in y value, or so giving maximum or minimum value. So this has no role, so just concentrate on r. Let's go to mistake number 10, the final one. It's about, again, integration of, this time, trigonometric function. If I have sine square x dx, it looks very simple, but it is not easy to integrate it without using this particular identity. So cos 2x equal to 1 minus 2 sine square x, right? So let's bring 2 sine square x to the left and cos 2x to the right. So it becomes 2 sine square x equal to 1 minus cos 2x, right? Then divide this by 2, divide this whole thing by 2. So sine square x equal to 1 minus cos 2x over 2. This is the identity we will use here to simplify. So this becomes, we can separate the numerators, 1 divided by 2 dx minus then cos 2x divided by 2 dx. What I want to tell you here that with an exponent, we can't simply write sine cube x over 3. No, it is only for linear. That's what I told you one of the previous parts. So first convert this into this format or using this identity, and then you can integrate this easily. Never ever try to integrate a square by itself. So the integration, this will be half x minus half, then cos 2x, its integration is positive sine 2x over 2, so this becomes 4. 2 times 2 is 4 plus c. That's the answer. Very simple in one step, but if you know this identity.